So let's get started just with a quick refresher of what it means to solve. All right. And we are solving. So there's a set of procedures. Usually the first thing you want to do is clear fractions. And the way that we clear fractions is usually to multiply across by the LCD, right? The least common denominator. All this stuff sounding somewhat familiar. Maybe it's deep in the brainstem, maybe it's rusted over a little bit, but it's somewhere in there. Your next goal is to clear parentheses or otherwise grouping notations, right? And usually the way that we clear those parentheses is with distributing. Once you've cleared any fractions, cleared any grouping symbols, you can combine like terms. And then you're going to either add or subtract. To get the variable on one side. And then you're going to multiply or divide to get the variable alone. So these are our general steps for solving, and you've hopefully been exposed to them at some point. All right. So let's say that I give you two x plus 7, all divided by 8, minus 2, set equal to x plus x minus 1, all over 2. All right. So here we've got an equation. How do I know it's an equation?
There's an equal sign.
Yeah, there's an equal sign. All right. And we want to solve. That means getting the variable by itself, right? So if we look at our steps, what's the first thing we should do? Clear the fractions. Right, you guys are usually allergic anyway, so you get to kill them off first step. That's nice. So we need to identify our LCD, our least common denominator here. What is the LCD? One person with confidence. Great. Right? So just look through your denominators. All right? We've got 8. We've got 2. What are the denominators for those other terms? Just 1, right? So what is the common denominator with 8, 2, and of course 1? It's got to be 8, right? That's your least common denominator. All right, so then we take our equation and multiply it all by 8. On both sides. What you do to one side, you have to do to the other, right? So this means on the left, I'm distributing that 8 to 2 terms, right? Because I have one term minus another term. So what happens with this first term? When I multiply it by 8, it's being divided by 8, right? So it's going to cancel out. So we just get the 2x plus 7. You guys okay with that? What happens with the second term?
Multiply by 8.
Yeah, 2 times 8?
16. Minus 16.
Minus 16 it is. Is everybody okay with that?
Yes.
Then we do the same thing on the other side. I'm going to have to distribute that 8. And once again, we happen to have 2 terms in there, term plus term, right? So what happens with the first one? 8 times x is 8x. And then with the second term, I'm multiplying by 8, but I'm dividing by 2. So that's going to wind up reducing to a 4.
Oh, divide 8 by 2.
If I multiply by 8 but divide by 2, what's 8 over 2? And it's going to be 4, right? Times the x minus 1. All right, so periodically I pan around the room, and what I'm looking for is for some neck action out of you guys. Nod, letting me know that everything's good. Shake your head, let me know you fell off the back of the bus. We'll stop, pick you up, brush off the road rash. All right? Just don't be drooling. All right? Other people sit there, it's gross. All right? You guys doing all right? Is this okay so far? Is this all right? You may be sitting in the back, I may be blind, but I can still see you. Yes? Is it okay? No is okay too. I mean, I have to grade your test, so I'm going to know eventually. All right? Yes, yes, yes. It's okay. Yeah? All right. If it feels like I'm staring at you, I am. All right. Okay, so that was the first step. Clear the fractions. LCD was our tool. What's the next step? We got to get rid of those parentheses. And that usually means distributing. So what's in front of this first set of parentheses on the left?
1.
It's just a 1 up there. And 1 times anything is itself, right? So that's just going to be 2x plus 7 minus 16. On the other side, we've got 8x. And then we have to distribute the 4. So what's that going to give me? Plus 4x minus 4. Everybody okay with that? Is everybody on board? So cleared parentheses. Next up, combine like terms. Do I have any like terms that I can combine? On the left, 7 minus 16. So this means I have 2x, and then I have minus 9. You guys agree?
Yes.
Equals. What about on the right? Yeah, the x's are like terms. 8x and 4x makes 12x minus 4. Everybody okay with that step? All right. So once we have combined like terms, what's next? Yeah, we got to add or subtract whatever it takes to get the variable to one side and everything else to the other, right? So if we look at 2x minus 9 equals 12x minus 4, who's got to go? Okay, so if we make the decision to gather the variable to the left, we need to take care of that minus 9. How would I do that?
Add 9 to both sides.
All right, so I'll add 9 to both sides. And if I'm gathering the variable to the left, who else has to move? How am I going to move the 12x? So I'll subtract the 12x from both sides. And you only have to add and subtract to the like terms, right? So what do we get on the left? We have 2x minus 12x, that is minus 10x. Negative 9 plus 9 cancels. On the other side, 12x minus 12x cancels, but negative 4 plus 9 is 5. Okay. Now, I'm going to point out, this step right here is called a crutch, and you're never going to see it again. All right? You guys need to get comfortable adding and subtracting to both sides. What's my next step?
Dividing.
Yep. Multiply or divide to get the variable by itself, alone. So who's got to go this time? The negative 10. I got to get rid of the negative 10. So that negative 10 is being multiplied by the x, so I'm going to get rid of it by dividing. So negative 10 over negative 10 cancels out, and you're just left with x, right, which is what we wanted. And what about on the other side? Negative 5 over 10? Negative 1/2. It reduces. All right? So, once we get x by itself, we've solved. So your solution is negative 1/2. And we usually use braces, right, to write our solutions. Hopefully I didn't rock anybody's world too hard with this. All right? This is dipping our toe in the water before I push you in and tell you to swim. What does it mean to be a solution? Why is negative 1/2 special? What does it mean? That what? X could be anything. Why is negative 1/2 special? Ooh, satisfies the equation. That's very fancy sounding.
Plug in every X.
Plug it in and get the same answer on both sides.
Yeah, your original equation. If I plug in negative 1/2 for X, I'm going to get a true statement. 5 equals 5. I don't know if that's what it is, but that's true. What if I try any other X?
It won't work.
You'll get a false statement. 2 equals 9. That's not true. That's what it means to be a solution. Right? It's the one number, in this case, that would make that equation a true statement. Everything else would be a false statement. All right. Let's try another one. Again, this is a little bit of review. When I said parentheses, a more generic term is grouping symbols. And what other grouping symbols do we have out there? Well, let's say that I give you negative 2, and then I'll open up a brace. 7 minus, and then I'll open up a bracket. 4 minus 2, open up a parenthesis. 1 minus x. Close the parenthesis, add 3, close the bracket, close the brace. Equals. Whew. 10 minus, let's open up a bracket. 4x minus 2, open up a parenthesis, x minus 3, close the parenthesis, close the bracket. Now, just to show that I'm not entirely cold-hearted, there is something in that icy, dark cavity where my heart was supposed to be. I didn't give you any fractions. You're welcome. But just to let you know, there are other grouping symbols out there. Parentheses, brackets, and braces. Or if you were educated in the British system, brackets, square brackets, and curly brackets. Whatever, they're all out there. So, we don't have any fractions to clear, so step 1 is automatically done. But the next step is clear your grouping symbols, right? Now, that's going to take a little bit of work here. So how should we work it? From the inside out. Right? Just work it one step at a time from the inside out. So what am I going to clear first? I'm going to clear those parentheses. So look at where you actually have the parentheses. We'll clear it by distributing. So this means I'm getting rid of that innermost symbol. So those braces will downgrade to a bracket, and the brackets will downgrade to parentheses. So negative 2 bracket, 7 minus parenthesis, for what? What do I write next? Minus 2 plus 2x plus 3 parenthesis bracket. Is that equal? Are you guys with me on that? All right, on the other side, that's 10 minus. Bracket's going to downgrade, so that's parenthesis. And then what do I write inside this parenthesis? 4x minus 2x plus 6 in the parenthesis. Next action. Do you guys see how I cleared that first level of grouping symbols? Are you guys okay with that? All right. Maybe it looks intimidating, but are you guys okay? Okay. Now, you can approach this different ways, but if we stick with what we're doing, we're still trying to clear those grouping symbols, right? So what would I have to do next? Distribute again. All right, distribute again. So I've got negative 2. Now that's going to downgrade to a parenthesis. And then that's 7 what? Minus 4 plus 2 minus 2x minus 3. Is that equal?
Okay, so you remove the...
Did you times everything by negative 1?
You did indeed. Right? There was a negative 1 in front of that set of parentheses. That's why I picked that. And in fact, on the other side, what are we going to do there? Distribute a negative 1. So for the right, that's going to be 10 and then minus 4x plus 2x minus 6. So far, so good. Did we finish our parentheses?
No.
There's one more set, right? So we're going to do it again. What are we distributing this time?
-2.
All right, so on the left, you guys tell me what to write. -14 plus 8 minus 4 plus 4x plus 6. You guys agree? Now, we didn't have any parentheses on the other side, so nothing to do there. And now, at long last, we've cleared all of our grouping symbols. What do?
Combine like terms.
Combine like terms. Now, I know some of you guys might have combined like terms as a mid-step along the way. That's totally fine. But just to stick with our rules, this is a clean way to do it. So what are my like terms here? Well, on the left, I've got -14, 8, -4, and 6. So if I combine all those like terms, I have a 4x, because that's just all by its lonesome. Minus 4. You guys back me up? I just mathed on the fly, so it helps if you guys back me up. Strength in numbers. Works for zombies, works for math. You guys agree? What about on the right? What are my like terms there? You got 10 and minus 6, but you also have -4x and 2x. You guys agree? So let's do our variables. What is -4x and 2x going to give me? -2x. And then 10 and minus 6? Plus 4. We all agree?
Because this one's positive.
Yep. 10 is bigger, so the answer is still positive. If you have $10 and you lose $6, you still have $4. Right? Put money to it, and then it all makes sense. Or it doesn't, and you're going to be bankrupt really soon. Is this all right? You guys with me? All right, next step. We got to add or subtract to get the variable to one side, right?
6x.
So if I'm going to add that 2x over, you made the decision to gather it to the left, that's fine. So I'm adding the 2x, right? What's that going to be? 6x on the left. You guys agree? But who else has to move then?
Minus 4.
That minus 4 has to go to the other side. So I would add 4. So what's that going to give me?
Plus 8.
So we got equals 8. Is that okay? All right. So I subtracted the 2x over, or actually I added the 2x over, so that gave me 6x. And I added the 4, which gave me 8. You guys okay? And my last step is to divide. Multiply or divide to get the variable alone. So what do I have to do here? Divide by 6. So I get x equals 8 over 6. So those blue crutches that I wrote on the first step, they're still there, right? Those aren't steps. They're just memorization devices. The sooner you can free yourself of it, the faster you can move. All right? I'm going to get you running, Forrest. Running. All right. 8 over 6 reduces. Is that okay? So I have a solution?
Yes.
My solution is 4/3. And what does that mean?
Plug it in and get a true statement.
Yeah, that's the number. If you go back to your original equation, if you plug in 4/3 for x, you'll get a true statement. Anything else? It'd be a false statement. Like 0 equals 2. That's not true. Okay, so in 10.8, which is our first section we're covering, we're talking about linear inequalities. Now, what are the inequality symbols? Yeah, we got greater than, we got less than. There's actually,
There's one with lines too, less than or equal to and greater than or equal to.
so here I've written greater than or equal to and less than or equal to. These are inequality symbols. All right? Yeah, now what happens is, unlike equation, if x equals 4, what is the solution? 4, that's it, right? Only 4 equals 4. Does 2 equal 4? No. Does 5 equal 4? No. Only 4 equals 4, right? However, if I have something like x less than or equal to 3, now how many solutions do I have?
Mine,
A lot.
A lot.
Like-
In fact,
like infinity.
infinitely many. So can I list them all?
No.
No, I die before I finish one example. And that's not a good use of my time. Right? Because how many numbers are less than or equal to 3? Is 2 less than or equal to 3?
Yes.
Yes. Is negative 5 less than or equal to 3? Yes. Is negative pi less than or equal to 3? Yeah, there's a lot. So there's two ways we can handle this. One way, which you've hopefully seen before, is to graph. All right? So we could go to a number line, go to 3, right? Go actually to 3. And then we choose a circle. Now we either do a closed circle or an open circle. Now here's the deciding factor. 3 less than or equal to 3. Is that true or false? That's true, right? 3 less than or equal to 3 is true. Any controversy? So is 3 part of my solution? Then I'm going to use a closed dot to represent that it's also good. And then shade less than. So for example, is 2 part of my solution? Yes. Is 5 part of my solution? No. So that's one way of doing it, graphing it. All right. We have another way of doing it, and this is using interval notation. Now the way interval notation works, if you're looking at the graph, just read it from left to right. So where does my shading start?
23.
Yeah, if we're reading it from left to right, it starts all the way at the beginning of time, right? In the beginning of time,
Infinity.
negative infinity.
3.
And we're going to put a parenthesis on that. Comma. And where does my shading stop?
3.
Is 3 included?
Yes.
Then I'm going to use a bracket. All right. So, parenthesis, negative infinity to 3, bracket, is interval notation for this graph. It's reading it from left to right, telling me where the shading started, telling me where the shading stopped. Is that all right? There was the equal to part there, which translated to a closed dot on the 3, which translated to a bracket on the 3 in interval notation. Is that okay? So what if I were to give you x is less than 5? All right, again, how many solutions do I have here? Infinitely many. There's a lot of numbers that are smaller than 5. So if I go to graph it, do a number line, go to 5, right? And what kind of circle am I going to do this time? I mean, the nature of T-tree type examples, I did one closed. You suspect this one's going to be open. Right? But the reason for that is 5 less than 5. Is that true or false? Is 5 less than 5? No, that's not true, right? So 5 is going to not be part of our solution. So we do an open circle. Is 4.9 there? Is 4.99 there? Is 4.999 there? Is 4.9999 there? Yeah, everything all the way up to 5 is there, but not 5 itself, right? So I'll shade down, and that includes all of those numbers. So that's the solution graph. For our interval notation, where does it start?
Infinity.
We got negative infinity. Once again, we start way back at the beginning of time. Negative infinity. And where does it stop? 5. But this time is 5 included? No. So I use a parenthesis. All right. So we've got parenthesis, negative infinity, comma, 5 parenthesis. This is our interval notation for that graph. So if we notice, this time we didn't have that equal to. We didn't close that circle off. We didn't use a bracket. Is that okay? All right. So if you do have the equal to, it's a closed dot, it's a bracket. If you don't have the equal to, it's an open dot, it's a parenthesis. All right? That's all whether you actually reach that number or not. We did reach the 3. We did not reach the 5. Does that make sense? So what about the negative infinity? Why did I use parentheses then? Would I ever use a bracket for infinity or negative infinity? No. And the reason for that is infinity is not a number you can actually stand on, right? So it's always going to be a parenthesis for infinity and negative infinity. Let's try another one. What if I want x is greater than or equal to negative 1? So you guys help me graph it. What should I do? Hint, I've drawn a number line. Go to negative 1. And once I'm there, what do? You do a closed circle. Again, you're asking yourself, negative 1 greater than or equal to negative 1. Is that true? Yes, that is true. And this time I shade greater than, so to the right. You guys okay with that? So for interval notation, right, we read left to right. And that's standard English, right? This is not Hebrew or Japanese or Arabic. Right, so we'll read left to right. Where does my shading start? Negative 1. This time it starts at negative 1. And is it included?
Yes.
Yes, which means bracket. So I got a bracket and a negative 1. Where does it stop? Yeah, we go off into the sunset. So that means we're going to go all the way to infinity, and that's going to take a parenthesis. Is that okay? So what is this telling me? Is 0 part of my solution?
Yes.
Yes. Is 5 part of my solution? Yes. Is negative 1 part of my solution?
Yes.
Yes. Is negative 2 part of my solution? No. And you can either do that visually with the graph or with the interval notation. It's telling you the same information. Are you guys okay with that? Okay. So what we can do now is we can take those steps that we had for solving equations, and guess what? Those are the steps for solving inequalities. Whew, that's nice. We get to recycle, right? That always makes for good. There's one little hitch in those instructions. On the very last set, multiplying or dividing to get the variable alone. And potentially on the first step, right, when we're clearing fractions, because how do we clear fractions? We multiply both sides by an LCD, right? Potentially on this step as well. When you multiply or divide by a negative number, your inequality is going to flip. All right? If you multiply or divide by a negative number on both sides, your inequality is going to flip. The same thing happened with the equal sign, but if you flip an equal sign, it's still an equal sign. So we didn't bother you with it then. Right? But now we do. Everything else is the same. What happens if I add to both sides? Nothing, right? What happens if I subtract to both sides? Yeah, it stays the same. Nothing happens, right? What happens if I multiply or divide both sides by a positive number? Yeah, it stays the same. Nothing happens, right? Only when I multiply or divide by a negative number, what happens? You flip the inequality, right? There's a lot less flippage than you think once I've told you about it, right? And there's more flippage in you guys driving. Yeah, some of you get it. If you've ever driven in Orlando, you get it. All right. So what if I looked at 3 minus 2 times parentheses 5 minus x set greater than 3 times x plus 1 in parentheses plus 1. So we want to solve this inequality. So first, do I have any fractions? No. So step 1's automatically done. Right? What do I do next? Yeah, we're going to use distributing to clear those parentheses. So what do I write for the left side? Hint, it starts with a 3. 3 minus 10 plus 2x. You guys agree? What about on the right side? What would I write there? 3x plus 3 plus 1. What about that inequality sign? Stays the same. You guys on board? What comes up next? Combine like terms. All right. What are my like terms on the left? 3 minus 10, what's that going to give me? So negative 7 plus 2x. If you wrote that as 2x minus 7, is that the same? Yeah. Negative 7 plus 2x and 2x minus 7 would be the same. What about on the right? 3x plus 4. My sign stays the same. I told you it was not going to be as exciting as it sounded at first. What do we do next? Well, if you decide to gather the variable to the left, then who would have to move? All right, so I could add the 7 to the other side, right? If I add the 7 over to the right, that's going to give me an 11. Who else has to move?
3x.
The 3x, I'm going to have to subtract it
Minus 1x.
to the left, right? So 2x minus the 3x gives me negative 1x. You don't have to write a 1, right? So just minus x is okay. You guys all on board with that? What about my sign? Stays the same. Adding and subtracting is never going to change the sign. Right? What's the only thing that does? Multiplying or dividing by a negative number. Funny I asked you that question right now. It's almost like I saw it coming. What's our next step? All right, if I divide by a negative 1, negative divided by negative becomes positive, and then positive 11 divided by negative 1 becomes negative, and my sign flips because I divided both sides by a negative 1. Is that okay? All right. Now, with both equations and inequalities, there's no rule that says you have to put the variable on the left. All that you have to do is get the variable by itself. With inequalities, it's nice to put the variable on the left because it's easier the way we read it. All right? But again, that's only a convention. So, how do I represent my solution? 2 ways. Graph it. Here's a number line. What do? Go to negative 11, and then choose an open circle, and then, yep, shade the lesser side. Lesser would be to the left. On a number line, smaller is to the left, larger is to the right. You guys agree? There's a little cheap trick. If you think of your inequality as an arrow, it points the way. All right. You can always test. Is negative 12 part of my solution? Is negative 12 less than negative 11? Yes, that's the true side, right? Is negative 10 part of my solution? No, that's the false side. Is that all right? Now what about interval notation? We start at negative infinity with what kind of punctuation? Parenthesis. So negative infinity and then to negative 11? Parenthesis. Is that all right? What if I give you 3 minus 4x over 6? Oh, my benevolence has ended. The fractions are back. Minus 1 minus 2x over 12 less than or equal to negative 2. We're going to solve this inequality. First up, do you guys like the fractions? No. So the first thing we do is kill them. Okay? This should satisfy your bloodlust. And what's our weapon of choice? That LCD, the least common denominator. So what would be the LCD here?
12.
Is everybody okay with the LCD? Let's see some neck action. Okay. You guys okay? Do you see how I picked the 12? I didn't pick it, your classmates picked it. Do you see what they did? Okay. You guys okay? Yes? Yes? Okay. So look at your denominators. We got a 6. We got a 12. And then what's the other denominator there? Is a 1, right? Is over 1. So when we talk about a least common denominator, what can you put 6 and 12 and also 1 into? What can you put 6 and 12 into? 12. Does that make sense? Now, there are many common denominators. Can't 6 and 12 both go into 24? So 24 is a common denominator. When we say a least common denominator, we're looking for the smallest possible number that they can both go into. Does that make sense? All right. LCD is going to be a very important tool in your tool belt, so it's going to stick around for a long time. All right. So this means I'm going to multiply both sides by 12. All right. So if I multiply both sides by 12, let's pluck the low-hanging fruit first. On the right, if I multiply by 12, what's that going to be? Negative 24. Right? Is everybody okay with that one? Right. I got to multiply both sides by 12. Well, negative 2 times 12 is negative 24. Everybody okay with that? When I multiply my first term by 12, so I'm multiplying by 12, but isn't that division by 6? So what does that mean? If I multiply by 12, but I'm dividing by 6, 12 over 6 is 2. It reduces. So we have 2 times the 3 minus 4x. Is everybody okay with that? What happens to my second term if I multiply by 12? Yeah, multiplying by 12, divide by 12. So those are going to cancel out and just leave you with 1 minus 2x. But there's something very important here. You need to keep parentheses. All right? That's very important. And the reason for that is this. didn't this negative apply to the whole fraction? So if I get rid of the denominator, shouldn't the negative still apply to the whole numerator? So we need those parentheses there. All right, it's a very common mistake. What about my inequality sign? Yeah, after all that, it stays the same. No excitement. It's less than or equal to still. Are you guys all okay with that step? All right? That's the worst one, because I know you see the fraction, you start getting blotchy. Right? But it's dead. What's my next step then? Clear those parentheses by distributing. So from the first set, I distribute the 2. What's that going to be? 6 minus 8x. And then for the second set of parentheses, what am I distributing? A negative 1, right? So what's that going to be? Minus 1 plus 2x. You guys agree? We still have that negative 24 on the other side, and my inequality sign stays the same. But didn't I multiply by a negative here? Isn't that distributing a negative 1? So why doesn't it flip? Yeah, you didn't multiply or divide both sides by a negative. Right? That's the key. I'm telling you, it does not flip very often. Right? It's just the one case when you multiply or divide both sides by a negative. Is that okay? So it did not flip. What's my next step then? Combine like terms. So, well again, the right side is easy. It's just negative 24, right? What about the left side? We'll have negative 6x. And it's actually plus 5. That's okay. I appreciate you guys participating over being accurate in class because we're learning, right? And then on the test, you can get it right rather than saying it out loud, right?
So if I have it flipped, I'm still going to get the right answer, right?
Yeah, so if you wrote 5 minus 6x, that's the same thing. You saved yourself 2 pen strokes because you didn't have to write the plus. What about my inequality sign? Stays the same. All right, next up, we want to get our variable to one side. Well, this time that's actually a little bit easier than it has been before because I only have one term with an x in it anyway. So who's the only one that's got to move? So if I subtract the 5 over, I get negative 6x left on the left. And on the right, negative 29. I'm going to subtract that 5 from negative 24, and I get negative 29. My inequality sign stays the same. My last step, divide both sides by negative 6. So that means I get a positive x on the left. Negative divided by negative is positive. And negative 29 divided by negative 6. Negative divided by negative is positive. But 29 over 6 doesn't reduce. Right? What about my inequality sign? Because we divided both sides by negative 6, we flipped the inequality. Is that okay? So do we have our solution? Yes. So we can represent it. The way that it's represented right now is part of what we call set builder. You should have seen something like that before. We can graph it. So I'll draw my number line and what? Go to 29 over 6. Nobody said it had to be pretty. And then put a closed circle. And then greater would be to the right. Bigger numbers on the number line are on the right, right? So what's my interval notation? Yep, we've got the 29 over 6 with the brackets for punctuation.
Positive infinity.
Go off to positive infinity.
Not gonna put brackets.
Nope, just a parenthesis. Right? Infinity is not a number you actually reach and stand on, so it's a parenthesis. Okay. You guys okay with that? Is that all right? So let's see what happens with the next one. Cackle, cackle. So let's say 4x is less than 4 times x minus 2. No fractions, you're welcome. But what do I do next? Distribute to clear the parentheses. So 4x on the left and on the right. 4x minus 8. And my inequality sign stays the same. All right. What do I do now? Well, the next step is to gather the variable to one side, right? Let's say we choose the left. Then what do I have to do? I need to subtract that 4x over to the left, right? But 4x minus 4x?
You can't.
0.
0.
Right? If you have 4 bananas and you lose 4 bananas, what do you have? No bananas. If you say you still have a banana, I don't know where that came from. I may not want to know. All right? 4x minus 4x is 0. Nothing left. Inequality sign? Stays the same. Now, I know it just freaks you out because the x just went away, but that can happen, and that's your red flag that we're dealing with one of our special cases. So when the x goes away entirely, we're left with this statement, 0 less than negative 8. This is false. 0 is not less than negative 8, right? Negative 8 is a smaller number. So this is a false statement no matter what. There's nothing that makes this statement true. You guys agree? But what did it mean to be a solution? When we were finding solutions, what did you guys say that was the whole point? What did it mean to be a solution?
Make a true statement.
It's what made the statement true. And this is telling me that nothing makes the statement true, right? So in words, we'd say there's no solution. There is no real number you could have picked that would have made a true statement in this inequality. In symbols, there's 2 ways that we can do this. All right? Remember how we were putting solutions inside braces? Well, what if I put braces and then don't put anything there? What do you think that means?
No solution.
No solution. Don't put 0, because if you put 0 there, you're saying there is a solution, and it's the number 0, right? This is saying no solution when it's empty. And in fact, we call that the empty set. There's another symbol. I'm not going to encourage you heavily to use it, especially at this level, but it's the null symbol. All right? So no solution in words. The empty set, if you just write the braces with nothing in it, or the null symbol. Now, that's not 0. That's the null symbol. Any of these mean the same thing. And that is, nothing makes this true. No answer would work. So let's try another one. And now that I've already baked your noodles with one special case, there's another. Let's say that I give you eight times x plus 3 in parentheses minus 7 times x plus 5 in parentheses less than or equal to x. Again, no fractions, so we caught a break there. The number God smiled upon you. What's next? Yeah, clear the parentheses with distribution. So we would have 8x plus 24, and then minus 7x minus 35. On the other side we have x, and your inequality sign stays the same. You guys agree? Now what? Combine like terms? All right, so that leaves me with 1x, which we could just write as x, because 8x minus 7x is just 1x. Then we have minus 11. Is that true? And x on the other side, and my inequality symbol stays the same. So x minus 11 less than or equal to x. You guys agree? What do I do now? If I want to get x to one side, one of those has to move. So I could subtract the x over to the left, but x minus x is 0. So I'd have negative 11 less than or equal to 0. Right? Again, if the x drops out entirely, that's not something you did wrong. It just means you're dealing with one of the special cases. Right? Now, the last one, this wound up being a false statement no matter what, right? But what can you say about negative 11 is less than or equal to 0? This is a true statement. No matter what you do, negative 11 is less than or equal to 0. That's a true statement. So what does it mean to be a solution? Any number that when you plug it in, you get a true statement, right? But this is telling me that it doesn't matter what I plug in because it's always going to be true. So what can I plug in? Anything I want. Anything I want. Right? You could list them all, but you die before you finish this one example. Right? So on a number line, shade everything. In interval notation, then, what would we write for interval notation? Yeah, start at the beginning of time and ride off into the sunset. Negative infinity to infinity. And those always take parentheses. And there's your interval notation. So in interval notation, negative infinity to infinity. What does that mean in words? Yeah. All real numbers. I don't particularly like that statement for some things that happen later on, but these are all three representations of the solution. The whole number line shaded in, the interval notation negative infinity to infinity, or the words all real numbers. Right? This is the preferred representation using the interval notation. Right? But they're all three true. Is that okay? So that's your other special case. Right? The two extremes. Nothing will work or anything will work. And look at some applications. Applications means word problems. Right? Let's say that we look at number 113. Right? To earn a B in chemistry, Trevor's average on his first 5 tests must be at least an 80. Suppose that Trevor has scored 85, 75, 72, and 82 on his first 4 chemistry tests. Determine the minimum score needed on his 5th test to get a B in the class. All right, so the key thing is it's going to say, solve the application using algebra. So guess what that means you have to use? Hint, it's algebra. All right. All right, so anytime we're using algebra, the idea is there's something we don't know. And what is it that we don't know here?
The other test score.
That fifth test score. So guess what we could call it? Yeah, I mean, x is boring, but it's perfectly serviceable. So x is the fifth test score. Right? Now this tells me the average of those test scores has to be at least an 80. Now, a couple things here. What does it mean to be an average? How do you average numbers?
Don't you add all the numbers up and then divide by how many numbers there are?
Yes. Add up the numbers and then divide by how many numbers there were. You guys okay with that? All right. So if we're going to average, we add up the numbers. So that means we have 85 plus 75 plus 72 plus 82 plus x, because those are all the test scores, including the one we don't know. And then we divide it by 5. Right? How do you figure out your test average? Add up the 5 test scores and divide by 5. Does that make sense? That's what we're doing here. Right? What a coincidence. You guys have 5 tests in here. All right. So this entire expression represents the average score, right? And in order to earn a B, it has to be at least 80. So how am I going to write that in there?
Is it greater than or greater than?
Yeah. Greater than or equal to 80. Everybody on board with that? Well, then what we're looking at here is, not coincidentally, what we've been doing this whole time. Solve an inequality, right? So what do you want to do? Yeah, kill the fraction, right? That's the Wicked Witch. Drop a house on it. So how are we going to do that? LCD here is 5. Maybe that one was so easy it was hard. So if I multiply both sides by 5, it's going to cancel on the left and just leave me with the numerator, right? And then that's going to be 400. You guys agree? And my inequality sign stays the same. What next? Combine like terms. So basically that's going to be all these numbers. So 314 plus x is greater than or equal to 400. You guys agree? All right, then what do we do? Add or subtract. So in this case, we're going to subtract the 314 over. So that's going to leave me with x. On the other side, that's going to be 86. And my inequality sign stays the same. And then the final step is to multiply or divide to get x by itself, but in this case that's already done, right? But we answer words with words, right? That's how it works. So what were they asking us to find? What does Trevor need on his 5th exam? So what's our answer? Trevor needs an 86 on test 5. Is that okay? Why don't we take a look at number 118? All right. Just for those of you out there who might be business-minded. All right. So here we have, Melissa runs a landscaping business. She has equipment and fuel expenses of $313 per month. If she charges $45 for each lawn, how many lawns must she service to make a profit of at least $600 a month? All right. Now, just some very basic business. All right. Let's talk revenue. Revenue is the money you take in, right? So how much money do you make? Well, she's going to make $45 for every lawn, right? So in general, revenue is price times X. If she mows one lawn, she's going to make $45. If she mows 2 lawns, she's going to make 45 times 2, which is $90. Make sense? Okay. But if there's revenue, there's also cost, right? You have to spend money to make money. Everybody knows that, right? So what's your profit? Yeah, the difference. And that's such a nice way to phrase that because it is, in fact, subtraction. Your profit is your revenue minus cost. Now, these are not formulas I'm necessarily going to beat you over the head with, but they're good business formulas that are out there. Your profit is how much you took in minus what you had to pay to get there. Reasonable? Then let's approach our exercise with this. What is it that they're asking us to find? What is it we don't know? How many lawns? That's the question, right? So, I don't know, M. Let's let M be lawns mowed per month. You can use X, but you know, it's boring. All right, so we want her to have a profit of at least $600 a month. So how do we get profit? Well, we will get to that, but how do we get profit? Revenue minus cost. So what's her revenue? How much money does she make? $45 times M, right? That's price times the variable. Minus, what's her cost? $313. So this expression represents her profit. You guys agree? All right, so we want a profit of at least $600 a month. So what does at least tell us? Greater than or equal to 600. Is that okay? You guys with me on that? All right, now there is lots of mercy in the universe. There are no fractions, step 1 done. There are no parentheses, step 2 done. There are no like terms to combine, step 3 done. But then, who's got to move? So we're going to add the 313 over to the right. So we get 45M, and that's going to be 913. You guys agree? And my inequality stays the same. You guys agree? Next step, divide by 45. So M is greater than or equal to 913 divided by 45. Did I have to flip my inequality? I mean, I wrote it there, so you know the answer is no, but why? Yeah, I divided by a positive 45, and you only flip when you divide or multiply both sides by a negative number. Okay, so let's see what 913 divided by 45 works out to be. So I have my trusty sidekick here, all right, my fake calculator, but it's just as real as yours. So we got what? I already forgot. My short-term memory stank.
913 divided by
All right, 913 over 45. So that's not going to come out to a nice number. All right? So we've got 20.28 repeating. I can use a little bar. But how do we answer words? With words, right? You don't go and say, m is greater than or equal to 20.28 repeating. There's your answer. That's not going to mean anything to this businesswoman. Actually, she's probably smarter than that. She could figure it out, but it's bad form. So what should I say? How should I answer this in words?
You could round it, 21 lawns.
You're going to have to, because I don't think she's going to mow a fraction of a lawn and then call it quits.
Right.
All right?
You have to move at least 21 lawns. Like, nope, I'm done now. That's it.
Yep.
I'm going home.
She needs to mow at least 21 lawns per month to make that profit, or at least that profit. Is that okay?
So in the last problem, we discussed that we came up with the at least to configure to the greater than, less sensible, equal to. So we said that he needed an 86 on test 5, but this one is at least 22 lawns. But how
You
do
could have said at least an 86.
Okay.
Yeah, yeah. I'm not going to persnick too hardcore on things like that. That's a good question to bring up. Right? But at least is the better form. Is this okay?